Hi everyone. Let's try to discuss about the epicyclic input and output relation. This is a continuation of matching of electric motor and IC engine. Just want to see about this, how this ring gear, planetary gear and sun gear are connected. You can see our previous video. Now let us try to see this configuration. So here I'm going to have the first configuration. So already I told we have ring gear and we have carrier gear and we have sun gear. Okay. So sun gear is at center, carrier gear transmission, and outer one is called the ring gear. So now we are going to define how the input and output we are going to have. So in order to understand one gear, we are going to ground, and I'm going to give the input torque to the ring gear, then automatically I'm going to get the output torque from sun gear. So here I'm considering the direction of rotation is a counter-clockwise direction, and the port which is grounded is nothing but a carrier gear is running with zero speed, which indicates this port is grounded, and input port is nothing but the ring gear. Now the output gear is nothing but sun gear. So we need the expression of sun gear in terms of ring gear. Therefore, I can write down, I will do the derivation later. Kindly, the relationship between output is sun gear. So this is output gear and this is input gear. The relationship between these two gears in terms of speed is the speed of sun gear is equal to minus k times the speed of ring gear. Okay, so this was the relation. Now let's try to see the second configuration, how we connect here. So here similarly we are going to have three types of gears: ring gear, center gear and sun gear. So here I'm going to connect this to the ground, and here I'm going to apply the input torque, and here I'm going to take the output torque, and here I'm assuming the speed of my rotor is clockwise direction, and which port is 0 is the sun gear is 0, and input is applied to the which gear, input is applied to the ring gear, and output is taken across the center, I mean carrier gear. So this carrier gear, and we need to link with the input gear, where input gear is nothing but the ring gear. So it is given by the formula k divided by k plus 1. No need to bother, I will show you the derivation of this in the next. Okay, so this is for the relationship between sun gear and ring gear, carrier gear and ring gear. So this is about the two configuration. Third configuration, we are going to have R, sun gear, carrier gear and sun gear. So here this one we are connecting to ground, and so here we are giving the input torque, and this is connected to ground, and here we are going to have the output torque, and the direction of rotation is clockwise direction, and here the grounded port is nothing but ring gear is equal to 0, the input is nothing but carrier gear, the output is nothing but sun gear. So the relationship between sun gear as well as carrier gear multiplied with 1 plus k. This is what the relationship between sun and carrier gear, sun and ring gear. Well, it's no need to bother, I will show you the derivation. So fourth one, we are going to have R, C, S, and this is grounded, and the input is carrier gear, and this is output gear, and the direction of rotation taken is clockwise direction, and what is grounded is nothing but the speed of sun gear is 0, and input is nothing but the speed of carrier gear, output is nothing but ring gear. So This is how many times it is k plus 1 divided by k. This is what the relation we have. So next configuration we have is, so here this ring gear is grounded and the input torque is given to the sun gear, and here you are going to have the output torque. The direction of rotation of the rotor is clockwise direction, and here the speed of ring gear is 0. The input torque is sun gear, the output torque is carrier gear, is equal to, so NC is equal to 1 by k plus 1 into NS. So all these are like small relation you can have in the derivation. So sixth configuration, when you come here, you're going to have, first one is ring gear, carrier gear, as well as sun gear. So here we are going to make this as ground. Here we are going to have input torque. Here we are going to have output torque, and the direction of rotation is clockwise direction. Here the carrier gear is 0 speed, and input we are going to apply to the sun gear, and ring gear is equal to minus 1 by k into sun gear. So what is the relation we are going to have? Let us try to see here. We have multiple relation between sun gear, ring gear, sun gear, carrier gear, carrier gear, ring gear. So how this derivation? Very simple derivation you can have. So the derivation is very simple. Let's try to define K as, okay. So the basic gear ratio as the speed of sun gear divided by the speed of ring gear. So therefore NR by NS is equal to minus K, or it is reverse of that, which is nothing but 1 by K. And you can define K as the basic ratio as the speed of sun gear minus the speed of carrier gear divided by the speed of carrier gear. So this is how we define the basic ratio K, which is nothing but epicyclic basic ratio. This K is called epicyclic gear ratio. Now from here I want to find out 1 plus K. So 1 plus K is 1 plus Ns minus Nc divided by Nc, which is nothing but Nc plus Ns minus Nc divided by Nc. Nc get cancelled. This is Ns by Nc. So here you can see here 1 plus K value is equal to speed of sun gear divided by carrier gear. Already you had got this the previous. So here you can see here Nc is equal to 1 by K. So you can write down Nc is equal to Ns into 1 plus K. You can see this relation here. Nc is equal to 1 plus K into Ns. This is what the relation we have. So next one, we are going to find out the ratio. So in order to find out this, I am taking N S is already here. Ns by Nc is equal to 1 plus K, and Nc by Ns is equal to 1 by 1 plus K. So when you are going to substitute these two values, I want the ratio of K divided by K plus 1. Okay. So the value of K already we discussed, minus Ns by Nr divided by Ns by Nc. Ns will get cancelled. This is Nc divided by Nr. Okay. So ultimately you can write down, if we take the magnitude, K divided by K plus 1 is equal to Nc by Nr. Now you can see here Nc is equal to K by K plus 1 times NR. You can see this relation. NC is equal to K by K plus 1 into NR. So this is how these relations are there. So speed of sun gear by ring gear is K. Carrier gear is equal to K by K plus 1 into NR. So this is how we have the basic relation between each and individual. Okay. So by using these three derivations, we can link all the equations. So K is equal to Ns minus Nr, Ns minus Nr, K equal to sun gear minus carrier gear by carrier gear. 1 plus K is Ns minus Nc, and K by K plus 1 is equal to Nc minus Nr. So by using all these three, we can attain clarity here how they are linked to each other. Okay. So only very simple, K equal to Ns by Nr, 1 plus K equal to Ns minus Nc, K by K plus 1 is equal to Nc by Nr. That's all. You see here all the three you can get. So this is how the formula are going to have. Ns is equal to K into Nr. So if you want this relation, so Nc into 1 plus K is equal to Ns. If you want this relation, Nc is equal to K divided by K plus 1 into Nr. From this you are going to have this. And when you come to this one, Nr is equal to Nc into K plus 1 by this one. Next relation you can write down from here. So Ns by Nc is equal to K plus 1. Okay, that's how all the relation we can establish by all the system by using these three formulas. This is how this epicyclic gear system helps us to interconnect one electric motor with an IC engine performance. So if you feel the content is useful, please like the video, share with your friends, and give your valuable comments. And this is a free channel. Subscribe this channel, which will help faculty and students to understand the basics of an electric vehicle with respect to the epicyclic gear set. So the purpose of this epicyclic gear set is already discussed. You can watch in the previous video. So the purpose of this epicyclic gear set is to match the performance of electric motor and IC engine with different speed ratio. Thank you for watching. We'll meet in the next video. Yours obediently, Ram.